Hello friends. Hello friends. In today's video, we are going to see some again more interesting topics related to collection framework. We will introduce some classes. So we were about with HashMap class. HashMap class extends abstract map and implements the map interface. Okay. So it uses hash table to store the map. This allows the execution type of get and put to remain constant even for large sets. Okay. What is the advantage of hash table? Execution time of getting the data from hash map and putting the data into hash map even for large sets. Hash map is a generic class that has this declaration class hash map key and value. Where key is what? K is for key and V is for value. Okay. K specifies the type of key and V specifies the type of value. Hash map. Constructors are hash map. Hash map extends K, extends V, M. This is the map object. Hash map integer capacity. Hash map capacity and field ratio. Okay. So first form constructor default hash map with default constructor. Second, initialize the hash map using elements of M like map extends K and V. So element using these elements of M, same elements will be added to this hash map object. Third form initializes the capacity of the hash map to integer capacity. Okay, this is the integer capacity. And the fourth form initializes both the capacity and field ratio of the hash map by using its argument. Capacity is equal to the capacity, integer capacity, and float field ratio. Okay, so this way, meaning of capacity and field ratio is the same for hash set, like default capacity 16 and default field ratio is 0.75 when field ratio is not specified. Hash map implements maps and extends abstract map. It does not add any methods extra. Hash map does not guarantee the order of elements. Order in which elements are added not necessarily same will be same the order in which they are read. Okay, so ordering of hash map is not guaranteed. Okay, so when you are adding the elements and when you are reading the element, there will not be same sequence present. We will see the example of hash map. It maps names to account balances, who is having how much balance in their account. Notice how a set view is obtained. Now to iterate, string double. So name will be stored as the name of the person using string. Double will be your account balance. Okay. So John Doe is having 3434.34 currency in their in his account. Tom Smith is having 123.22. Jane Baker is having 1378.00. Todd Hall is having 99.22. Ralph Smith is having minus 19.08. Now we are getting the set view and to iterate through a map. So how to get a set view? Hash map object dot entry set method is available. So this will be converting your value to a set object set, and for map entry string double me colon set for each and every me into the set. We are having get key to get the key of the element and value of the element. Okay. So deposit 1000 into John Doe's account using hm dot put balance plus 1000. So what is the John Doe's amount? 3434.34. So it will be now 4434.34 after we are adding 1000 into his account. Okay. So first of all, how to get it? Using a key. Key is your string name hm dot get key and put at the particular key a new value. Okay, so John Doe's new balance will be 4434.34. Okay, so it is displaying each and every element's value and John Doe's new balance. The program begins by creating a hash map and then adds the mapping of names to balance. The contents of maps are displayed by using setView by calling entrySet method. The keys and values are displayed by calling the getKey and getValue methods that are defined by map.entry. Okay. How the deposit is made using the put method. This will automatically replace any pre-existing value with a new value. Okay, with the specified key and a new value. After John Doe's account is deposited, new value is because of overwritten method, it will be having still one John Doe's account. Okay. Now, tree map class. The tree map class extends abstract map and implements the navigable map interface. It creates maps stored in a tree structure. Okay. So tree map, as the name suggests, it is in tree structure. It provides an efficient means of storing key value pair in sorted order and allows rapid retrieval. Okay. So key value are stored in sorted order more efficiently than another classes, and more efficiently they are retrieved more speedily. Okay. Unlike hash map, tree map guarantees that elements will be sorted in ascending key order. Okay, hash map does not guarantee the order of element, but tree map guarantees. Tree map is a generic class tree map key value, where K is the type of key, V is the type of value. So constructors are tree map comparator, tree map object extends key value, tree map sorted map key and value. Okay. The first constructs the default constructor empty tree map that will be sorted by using the natural ordering of its keys. The second form constructs an empty tree based map that will be sorted by the comparator object. Okay. Empty tree based map, and this tree based map will be sorted by using the comparator comp, and this is comparator we will be seeing now after in upcoming slide. The third form initialize a tree map with key and value object with the entries from M, which will be sorted by using the natural ordering of the keys ascending order. The fourth form initializes a tree map with the entries from sorted map object, which will be sorted in the same ordering as of sorted map. Tree map has no methods beyond the specified by navigable map interface and the abstract map class. So extra methods are not there, so no need to learn them. You have to just learn the navigable map interface and abstract map classes methods. We will see one example, the same example with using the tree map. John Doe, Tom Smith, Jane Baker, Todd Hall, and Ralph Smith account balances are there. Getting the entry set, using the entry set, getting the set view of map, get key and get value, then system.out.println. Double balance, get balance, and then updating the balance. Okay. Here, only difference is that elements are sorted using the natural ordering of a key. So, what is the key? Here, alphabetically, all the elements are sorted, and then their values are account balances are displayed. John Doe's current balance is 4434. Okay. They are sorted by first name instead of last name. You can alter this behavior by specifying the comparator object when the map is created. Okay. Depending upon the comparator object, you can decide whether they should be sorted by the first name of the client or last name of the client. Linked hash map class. Linked hash map extend hash map. It maintains the linked list of the entries in the map in the order in which they are inserted. Okay. Entries in the map in the order in which they were inserted. Insertion order iteration over the map. So whenever you are entering objects into the map, the same order will be maintained. That is when iterating through a collection view of linked hash map, the elements will be written in the order they were inserted. Okay. You can also create a linked hash map that returns its elements in the order in which they were last accessed. Linked hash map is a generic class that has this declaration, class linked hash map KV. Here K specifies the type of key and V specifies the type of values. Okay. Linked hash map defines the following constructors. Linked hash map, then linked hash map with map object, linked hash map with capacity, linked hash map with capacity and field ratio, linked hash map with capacity, field ratio and order. The first constructor default linked hash map with default constructor, second initializes with elements of map, third initializes the capacity, fourth initializes with capacity and field ratio, and meaning of capacity is same as for hash map. Linked hash map adds only one method, that is the remove eldest entry, and it is shown here. Protected boolean remove eldest entry map dot entry KVE, and this is called by put and put all. Okay, the oldest entry is passed in E. This method returns false and it does nothing. Okay, by default. This does not remove anything, so it will give you by default false output, and it will do nothing if the removing of eldest entry is not successful. Okay, and this is called by put method and put all method. If you override this method, then you can have the linked hash map remove the oldest entry in the map, eldest entry. If you want to do this to remove the oldest entry, have your override return true. Okay, this is the overridden protected boolean remove oldest entry. Have your override return true and keep the oldest entry. Have your override return false. Okay. Then identity hash map class. The identity hash map extends abstract map and implements the map interface. It is similar to hash map except that it uses a reference equality when comparing elements. Identity hash map is a generic class that has this declaration, class identity hash map key value. Okay. It is similar to hash map class, but it uses a reference equality when comparing elements. Okay. So you have to remember this line. It is similar to hash map except that it uses a reference equality when comparing elements. And here K is a type of key and V is a type of value. API documentation explicitly states that identity hash map is not for general use. Okay, so not generally this class is used, so you don't have to worry. But in case if you have a question related to this class, what you will tell? It is a similar to hash map, except that it uses reference equality when comparing elements. Enum map class. Enum map extends abstract map and implements map interface. It is specifically for use with keys of enum type. It is a generic class that has this declaration, class enum map K extends enum K and V. Okay. Keys of enum type. Why you are using this class? It is specifically for use with keys of enum type. Here K specifies T type of key and V specifies the type of value. K must extend enum K, which enforces the requirement that the keys must be of enum type. Okay. Enum map class K, K type. Enum map K extends V, M. Enum map EM object. Okay. K must extend enum K. Here in this case, it is a generic class reference and enforces the requirement keys must of enum type. Okay. All other enum type, other type keys are not allowed, first of all, and there are three constructors over here. First is class K type, second is map object, third is enum map object. The first constructor creates an empty enum map. Second creates enum map that contains the same entries as that of this map object. And third, it creates an enum map initialized with the values in enum EM object. Okay. Enum map defines no methods of its own, then comparators. Okay. We have told that we will be introducing the comparators shortly. Both tree set and tree map store elements in sorted order. Okay. Tree set and tree map both are made for what? Sorted order. It is the comparator that defines precisely what sorted order means. These classes store their elements by using Java refers to as natural ordering, which is usually the ordering that you would expect A before B, 1 before 2, and so forth. Okay. When you are not giving the comparator, what they will follow? Natural ordering. What is the natural ordering? When there comes to alphabet, it will be from A to Z. When it will be come to 1 to 100, it will be from 1 to 100 in the smallest to greatest value. Okay. If you want to order elements in a different way other than natural ordering, what you will do? You will specify a comparator object. Okay. Then specify comparator when you construct the set or map. Doing so gives you the ability to govern precisely how elements are stored within a sorted collection and map. Okay. So comparator will tell you depending upon what you will be sorting the elements. Comparator is a generic interface that has the declaration interface comparator T. So if you want to use the comparator, you will implement that interface. T specifies the type of objects being compared. Comparator interface defines two methods, compare and equals. Okay, so what you have to have introduced now, first is compare method and second is equal method. Okay, the compare method shown here compares two elements for order. Integer compare T object 1, T object 2. Object 1 and object 2 are the objects to be compared. Okay, so what is the meaning of this? It will compare object 1 with object 2 and it will return 0 if the objects are equal. It returns a positive value if object 1 is greater than object 2. Okay, and it returns a negative value if object 1 is less than object 2. And it can throw a class cast exception if the types of the objects are not compatible for comparison. Okay, so there should be same type of object. You cannot compare string with integer, you cannot compare float with boolean and so on. By overriding compare, you can alter the way that objects are ordered. Okay, so what you have to do, if you want to implement this method, you will have to override the compare method. In to sort in reverse order, you can create a comparator that reverses the outcome of the comparison. The equals method is the second method. Test whether an object equals the invoking comparator. Okay, so boolean equals object. Here object is the type. Here object is the object to be tested for equality. The method returns true if the object and the invoking object are both comparator objects and use the same order. Otherwise, it returns false. Overriding equals is unnecessary and most simple comparators will not do so. Okay. The method equals will return true if both are equal and both use the same ordering. Okay. Otherwise, it will return false. If it is not equal to, it will return false. And generally, O equals is not overridden. Now, we have introduced about in comparator. Now, we will see how to use a comparator. The following is an example that demonstrates the power of custom comparator. It implements the comparator for strings that operates in the reverse of normal. Okay. It causes the tree set to be stored in reverse order. So, this class, my custom class, implements the comparator for string. Public integer compare string A, string B. This is the overridden method. String A, string B, string A, string is equal to A, B, string is equal to B. Reverse the comparison. Return B string dot compare to A string. Okay. So what we have seen, compare object 1 and object 2 are the objects to be compared, and if both are equal, it will return 0. If object 1 is greater, it will return positive value. If object 1 is lesser, it will return the negative value. Okay. So B string compared to A string, no need to override equals method over here. Okay. So tree set object is created of string, and here we are passing the new comparator output. So C, A, B, E, F, D. These are the elements we are added. Natural ordering is the basic ordering it will follow, but we have passed here comparator object. Okay. So display the elements for string element, ts, element and space. Output is the reverse order. Why reverse order? B string compared to A string. Okay. My comparator class, which implements a comparator and overrides the compare method. Overriding an equals is neither necessary nor not common. Inside compare the string method compare to compares the two strings. Okay, but B string invokes compare to, that is the second string compared to, we'll call the compare to, and outcome of the comparison to be reverse. So this is the reason why we have the reverse output. The following program is the updated version of tree map program shown earlier, that will store the account balances of the person. The accounts were sorted by name, but the sorting began with the first name. Now we will sort them by the last name. It uses the comparator that compares the last name of the each account, and it results in the map being sorted by last name. Now, string A, string B, A string and B string, I, J, K, three variables are created. Okay. I is equal to A string last index of space. J is equal to B string last index of space. K is equal to A string dot substring I compared to B string dot substring J. Okay. If K is equal to 0, last names match. Check entire name. Okay. So return A string compared to B string. Else return K. So K will have what? A string dot substring of I compared to B string of substring of J. Now, tree map object is created and comparator interface object is passed over here. John Doe, Tom Smith, Jane Baker, Hall and Smith. Okay. So what it will do first? Okay, here is also Smith. Here is also Smith. Here is Tom, Tom. Here Ralph. Okay. So what it will do in this case? A B C D E F G H I J K L M N O P Q R S T. So R comes first, T comes last. So first of all, when both last names are equal, Ralph will come first, Tom will come last. Okay. So here elements are got, then get key and get value. Then again add 1000 rupees or 1000 currency to the John Doe's account balance, and John Doe's new account balance is given. Okay. So last names ordering is used over here. Why? Because we have passed here the comparing for a string of first file index of beginning of last name. Okay. Here it has found out by using the I, last index of space and last index of space. When there is a name space between John Doe, after John there is a space. So after space, space is the first index. From that index we will start. So a string dot substring of I. Okay. So substring will start from John Doe. So Doe will be compared with Smith. And here compare to will call for the last names natural order. Okay. So now Jane Baker, John Doe, Todd Hall, Ralph Smith and Tom Smith, and output is displayed one after the another. Comparator class T compare compares two strings that hold the first and last name by first comparing the last name. Okay. So what it do? It finds the index of the last space in each string and then compares the substrings of each element that begin at that point. If in cases where last names are equivalent, the first names will be compared. Okay. This yields like in a we have seen in this example, both are Smith. So this is R comes first, T comes another. So these will be sorted. This yields a tree map that is sorted by last name and within a last name by first name. Okay. Ralph Smith comes before Tom Smith in the output of natural ordering. Then collection algorithm. The collection framework defines the several algorithms that can be applied to collection and maps. These algorithms are defined as static methods within the collection class. Okay, so there are several algorithms in collection framework, and these algorithms can be applied to collection and maps, and those are defined as static methods within the collection class. Beginning with JDK 5, all of the algorithms have been retrofitted for generic. Okay. Generic syntax might seem a bit intimidating at first. The algorithms are as simple to use as they were before generic. Okay, so these algorithms are very simple in short. It is just that now they are type safe, because type safety is the very basic advantage of the generics. We have already seen. Okay, so now we will see the algorithms defined by collection. Static Boolean add all collection super T C T elements. Inserts the elements specified by the elements into the collection specified by C. Returns true if the elements were added and false otherwise. Static T QT as LIFO Q DQTC. Returns the last in first out view of the C. Added by Java 6. Static integer binary search list object T value comparator C object. Searches for value in the list ordered according to comparator object. Returns the position of the value in the list or a negative value if the value is not found. Static T integer binary search list extends comparable super T list T value. Searches for value in the list must be sorted. Returns the position of value in the list or a negative value is not found. Static E collection E checked collection E C class ET returns a runtime type safe view of the collection and attempt to insert an incompatible element will cause a class cast exception. Static E list E checked list E C class ET returns an runtime type safe view of the list and attempt to insert an incompatible element will cause a class cast exception. Static map checked map class K key T K class V value T returns a runtime type safe view of the map and attempt to insert an incompatible element will cause a class cast exception. Static E list E check set returns check set EC class ET returns a runtime type safe view of the set and attempt to insert an incompatible element will throw a class cast exception. Static key value sorted map key value check sorted map key value C class K key T class V value T returns and runtime type safe view of the sorted map and attempt to insert an incompatible element will cause a class cast exception. Static E sorted set E check sorted set E C class ET returns a runtime type safe view of the sorted set and attempt to insert an incompatible element will cause a class cast exception. Static T void copies list super T list 1 list extends T list 2 copies the elements of list 2 to list 1. Static Boolean disjoint collection A collection B compares the elements in collections A to elements in B returns true if the two collections contain no common element, that is the collection contains disjoint set of elements, otherwise returns true. Static T list T empty list returns an immutable empty list object of the import type. Static key value empty map returns an immutable empty map object of the import type. Static T set T empty set returns an immutable empty set object of the import type. Static T enumeration collection C returns an enumeration over C. See the enumeration interface later in this chapter. Static T void field list super T list object assigns object to each element of the list. Static integer frequency collection C object obj counts the number of occurrences of object in C and returns the result. Static integer index of sublist list list sublist list comma list sublist searches the list for the first occurrence of the sublist returns the index of the first match or -1 if no match is found. Static index last index of sublist list sublist searches list for the last occurrence of the sublist returns the index of the last match or -1 if no match is found. Static T array list lists enumeration T enumeration returns an array list that contains the elements of the enum. Static T max collection extends T C comparator super T comparator object returns the maximum element in C as determined by the comparator. Static T extends object and comparable super T max collection extends C returns the maximum element in C as determined by the natural ordering. The collection need not be sorted. Static T minimum collection extends C comparator super T comparator returns the minimum element in C as determined by comparator. The collection need not be sorted. Static T extends object and comparable super T minimum collection extends C. It returns the minimum element in C as determined by the natural ordering. Static T lists C n copies integer number T object returns num copies of object contained in an immutable list. The num must be greater than or equal to 0. Static set new set from map boolean m creates and returns a set backed by the map specified by m, which must be empty at the time this method is called. Added by Java 6. Static T boolean replace all list T old T new replaces all occurrences of old with new in list returns true if at least one replacement occurred returns false otherwise. Static void reverse list T list reverses the sequence in the list. Static T comparator reverse order comparator object returns a reverse comparator based on the one passed in comparator. That is, the return comparator reverses the outcome of the comparison that uses comparator. Static T comparator T reverse order returns a reverse comparator, which is a comparator that reverses the outcome of the comparison between two elements. Static void rotate list T list integer n rotates list by n places to the right. To rotate left, use a negative value for n. Static void shuffle list T list random R shuffles, that is, randomizes the elements in list by using R as the source of random numbers. Static void shuffle list T list shuffles, that is, randomizes the elements in the list. Static T set T singleton T object returns an object as an immutable set. This is an easy way to convert a single object into a set. Static T list T singleton list T object returns object as an immutable list. This is an easy way to convert a single object into a list. Static KV map KV singleton map KV returns the key value pair as an immutable map. This is an easy way to convert single key value pair into the map. Static T void sort list T list comparator super T comparator sorts the elements of the list as determined by comparator. Static T extends comparable super T void sorts the elements of the list as determined by their natural ordering. Static void swap list integer index 1 idx 1 idx 2 exchanges the elements in the list at the indices specified by index 1 and index 2. Static T collection T synchronized collection T C returns a thread safe collection backed by C. Okay, so this way we have seen all the methods. In the next session, we will see some more interesting topics related to collection framework, more interesting and important classes. So meet you in the next session.